Welcome back to PromptWare, your hub for the latest in AI, tech, and future innovations. Today, we're diving into a breakthrough that could rewrite the rules of modern warfare. Quantum radar detecting stealth aircraft at a record distance of 300 kilometers. Conventional radar works by sending out radio waves and catching their reflections. But here's the catch. Stealth fighters like the F-22 and F-35 are designed to absorb or deflect those signals. This makes them nearly invisible, and for decades, radar systems struggled to track them. Quantum radar works very differently. Instead of relying on powerful radio emissions, it uses entangled photons. Here's how it works. When one photon interacts with an aircraft, its entangled partner instantly changes state. Scientists can measure those tiny changes, allowing them to spot stealth jets without broadcasting any detectable signals. That means pilots can't jam it. They can't even know they're being watched. In the latest field trial, Chinese scientists used this system to track a stealth fighter 300 kilometers away. That's nearly double the previous record. What's even more impressive is that it worked under heavy atmospheric interference, a challenge that used to cripple earlier quantum detection systems. This could be a game changer for global defense. First, it could neutralize stealth technology, which countries have invested billions in. Second, it makes radar harder to detect and jam, giving defenders a major edge. And third, if deployed at scale, a quantum radar network could shift the balance of power in the skies. Now, before we imagine stealth jets becoming useless overnight, the narrator cautioned, quantum radar needs to prove it can be scaled up, remain stable in all weather conditions, and be fully integrated with missile and defense systems, the narrator explained realistically. So while this test is groundbreaking, full deployment might still take years, the narrator added with measured optimism. Still, the idea that a radar can see the invisible, detecting stealth jets at 300 kilometers, is no less than revolutionary. This is just one example of how quantum technology is moving from theory into real-world applications. And the future of air defense may never be the same. That's it for today's episode on PromptWare. If you found this fascinating, hit like, subscribe, and share it with someone who geeks out over defense tech. And as always, stay tuned because the future is closer than you think. Let's take a moment to appreciate how far radar technology has come, from World War II systems to today's quantum leaps. Each innovation has not only changed battlefields, but also everyday life, impacting everything from aviation safety to weather forecasting. To wrap up, we've invited experts in quantum mechanics and defense technology to discuss the implications of quantum radar. Stay with us as they explore both potential and pitfalls of this cutting-edge technology. Hello, I'm Dr. Emily Zhang, specializing in quantum communication systems, she said professionally. And I'm Colonel Tom Harris, working with the National Defense Strategies Division, he added confidently. While it's promising, deploying at scale is the real challenge, as maintaining photon entanglement over vast distances is immensely complex. Expert 1 explained analytically. Indeed, but the potential to update defense systems with nearly undetectable detection capability could redefine military strategy worldwide. Expert 2 stated assertively. Ultimately, tackling these hurdles will lead us to technologies we only dreamed possible, Expert 1 said. Inspired. Right. And as these advancements unfold, you can bet we'll be watching closely to navigate the coming changes, Expert 2 replied, assured. With each new discovery, we're not just looking at the future, we're living it. Thank you for joining us on this journey. Thank you for watching PromptWare.